All right, welcome. Today we are talking about least squares regression. You may have heard this term before, or at least the part about regression. Regression lines are basically lines that take our data points and try to make a formula that will predict points either in between or outside of the data that we have, right? So usually this is something where you plot a bunch of points on a scatter plot and then try to find that line of best fit. We mentioned it in a previous lesson. So before, we kind of mentioned that the line of best fit just kind of runs through the middle. We need a way to come up with an actual formula for our line of best fit. So the first term that we want to talk about is residuals. So the residuals are the difference between the actual points in our data and the line of the regression line itself. So if we can minimize the residuals, we will have the most accurate line because the points are going to be as close as the line as we can possibly make them. The formula for this is the formula for finding our least squares. So if you notice, the notations are going to be very similar to what we've looked at before. This is essentially the point slope formula for the line, where the point we run through is the average of x and y. And we use the standard deviations to determine the slope of that line. So this is another use for the standard deviations that we were talking about before. So, given a set of data, we need to be able to fill in the formula that we were given so that we can get our line of best fit. So it looks like we're going to need to find a couple of things first. And so remember, our calculator can definitely help us out with this. So we need to know the average of both x and y, right? So let's use the list here. So if I go through, find the mean of the x row, I should get 4. And so again, if you just go into stat, go into edit, enter your list, your x should be in the first column, so you can say mean L1, and it should equal 4. So I'm just going to mark that down as x bar so I remember what's what. So we're going to do the same thing as y, right? So most likely we typed our y in the second column. So if I go to list and then ops, enter, it should give me about 12.857. It looks like we also want to know how many terms we're using because we're going to need it for our two variance formulas. So if we just count it out, right, there's 7 numbers in each list. It looks like we are also going to need the total of x squared and the total of x times y. So remember, you can make both of those lists in your calculator. So if you take L1 times L2 and you hit the store button, we can go ahead and put that into column 3. And then we can use our list operations to find the sum of L3. In doing that, we should get that the sum of x times y is equal to 431. If you're doing it by hand, again, you would just multiply the x's and y's together and then add your total. All right, so then we need the sum of the x squareds. So again, if we're doing this by hand, make a new column where you square all of your x values and then add them up. Or again, on your calculator, you can just take list 1 and square it. And since we want to keep that list 3, let's go ahead and put this in list 4. And then again, you would just find the sum of list 4. It should be 140. All right, so it looks like we have everything that we need. We just need to go in and find our two variances, right? So remember we said that standard deviation is the normal formula. Standard deviation squared gives you variance. When you see the S with the X and Y together, that is called your covariance. Because it is the variance of X and Y combined. Alright, so to get this, we're going to take the sum of X times Y, which we said was 431, divided by N, which we said was 7, and subtract out the two averages multiplied together. So 4 times 12.857. And if I do that, it should give me 10.143. Let's kind of keep that number in mind. Okay, now I need the variance of X. So we're going to take the sum of X squared, which we said was 140. We're going to divide it by N, and then we're going to subtract the average of X squared. And if we do that, it conveniently should come back out to 4. Alright, we have all of our information. So now we're just going to plug it into the point slope formula. Right, so we said Y minus the average of Y, which is 12.857, is equal to the slope of the line, which is the covariance, so 10.143, divided by the variance of X, which is 4, times X minus the average of X, which is 4. And so if you want to graph this on your calculator, then you just solve it for Y and type it in. And that is how we calculate a least squares regression given a set of two variables. There's another example for you to try on your own. That is all for today. I will see you next time.